Let's use what we know about shifting conic sections to sketch some graphs. For our first example, let's sketch the graph of this equation, x minus 5 squared equals minus 2 times y minus 1 squared. So the thing to notice is that this looks just like the equation x squared equals minus 2y, except there's been some shifts that have happened. So it looks like in the x direction, we've replaced x with x minus 5. And that means that we need to shift right 5. And in the y direction, it looks like y has been replaced by y minus 1. And that means we need to shift 1 in the y direction. And plus 1 in the y direction means up. So up 1 in the y direction. So what we'll do, and that will give us this equation that we want, x minus 5 squared equals minus 2 times y minus 1. So what we're going to do is sketch the graph of this unshifted equation, x squared equals minus 2y, and then we're going to do these shifts, and it will give us the graph of x minus 5 squared equals minus 2 times y minus 1. Okay, so let's graph the unshifted parabola first. This is a parabola, and it looks like it opens in the up-down direction because x is squared and y is unsquared. So it looks like, remember, the sort of general template for this equation is x squared equals 4ay. So 4a is minus 2. And that means that a is minus a half. Okay, so when we graph this, remember that this unshifted parabola equation, the vertex is always at the origin. This one is opening either up or down, and because a is positive, it opens down. A is the focal length, so if 1 is here, the focus is at minus 1/2. And also remember that 4a is the diameter at the focus. So if we go 1, 2, so the diameter at this focus is 2, so that's going to be like that. So we get these other 2 points on the parabola, so it's going to look like this. Okay. I should have this curling down a little bit. I don't want to give the impression that this parabola has a slanted asymptote like hyperbolas do. So got to have it going down a little bit more here. Okay. So this is the graph of the unshifted parabola. To get the graph of our shifted equation, we just need to shift this graph according to the shifts that we have noticed here. So we need to shift right 5 and up 1. So that's going to move this vertex 5 units to the right and 1 unit up. So 1, 2, 3, 4, 5, 1 unit up. So the vertex is going to be here. The focus is still going to be half a unit below the vertex, like that. And of course, this diameter at the focus is still 2. And that gives us something like this. So the same shape, maybe more like this, the same shape, but shifted so that the vertex is over here at 5, 1. All right, let's try another one. Let's sketch the graph of this equation. Y squared plus 4y equals 8x minus 4. So because there's a y squared but no x squared, it seems like this is probably a parabola. And since it's the y that's squared, probably if it is a parabola, we should start with this unshifted equation. Y squared equals 4ax. But if you look at this sort of template parabola equation, y only shows up once in the squared term. But in our equation, y shows up 2 places, one squared and one unsquared. So what we want to do is to somehow rearrange this equation so that y only shows up in a squared part, right? We want something with a y in it that's squared. And there's sort of a standard algebraic trick to make this happen, and it's called completing the square. So you've probably completed some squares before, but let's just review how it works. So we have y squared plus 4y. This is the part whose square we want to complete. And to complete the square, you need the squared term to have a coefficient of 1. And ours does have a coefficient of 1 already. So when your leading coefficient is 1, you take your linear coefficient, so the coefficient on the unsquared term, which for us is 4, you divide that by 2, and you square that. So it's always dividing by 2 and squaring. The only thing that changes in this recipe is what number you start with. And again, this 4, it came from the coefficient on the unsquared y term. So whatever that coefficient is, you always divide by 2 and square. Okay, so 4 divided by 2 is 2, squared is 4. So what we're going to do is we want to have a plus 4 here. That's what this sort of recipe gives us, what we would like to have sitting here. So we would like to have a plus 4 here. And we can have it, but right, we have to sort of pay the price for writing a plus 4. We have to balance that out somehow. And to balance that out, we can subtract 4 as well. Okay, and the other side of our equation is 8x minus 4. All right, so now this equation is y squared plus 4y plus 4 minus 4 equals 8x minus 4. So what we've done here is we've sort of intentionally unsimplified this so that we could have the plus 4 that we wanted. Now the reason we want this plus 4 is, if you look at these first 3 terms, these are a perfect square. In fact, it's y plus 2 squared. And then minus 4 equals 8x minus 4. So you can see this trick gave us what we wanted. It made it so that we had y showing up only in the squared term. All right, so now let's see. Our sort of template equation for our parabola doesn't have any constant term on this squared side, so let's add 4 to both sides here. That also has the effect of canceling this minus 4 right there. So we get y plus 2 squared equals 8x. Now comparing this to our unshifted parabola equation, which is y squared equals 4ax, it looks like, first of all, comparing the coefficients on x, it looks like a is 2. So now we know the focal distance. Also, it looks like we have done a shift in the y direction. So y has been replaced by y plus 2. And that's a shift down 2. Okay, and that would produce the equation that we started with, which is y plus 2 squared equals 8x. So this gives us a way to sketch our parabola. We can sketch the parabola right here, y squared equals 8x, and then shift it. So y squared equals 8x. Now, so y squared equals 8x. This is a is 2. And this one is opening in the horizontal direction because it's x that's unsquared. And the focus is 2 units to the right of the vertex. That's to the right of the vertex because a is positive. So in the unshifted equation, the vertex is at the origin, and then right 2, and there's the focus. Here's the vertex. And the focal radius is 4. Yes, the focal diameter is 8, and so the focal radius is 4. So 1, 2, 3, 4 here, something like this. Okay, so that's the unshifted parabola. Remember, we need to shift down 2. So let's shift down 2. So our vertex was at the origin, so now we go down 2. And our focus also moves down 2, so our focus was there at 2, 0, so now it shifts down. So there's our focus, here's the vertex, and our focal radius is still 4, so like that, and 1, 2, 3, 4, about like this. All right, so here's our parabola. Notice it looks just like the unshifted parabola up here, except, of course, it's been shifted. Okay, let's look at another example. Let's sketch the graph of this equation, minus x squared minus 8x plus 2y squared equals 18. Let's see, so which type of conic section might we expect? So it looks like both variables are squared here, so not a parabola, either a hyperbola or ellipse. And because there's a minus sign on one of the variables, it seems like probably we're going to end up with a hyperbola. That would be my guess. So we're either going, so the unshifted equation that we should be aiming for is either x squared over a squared minus y squared over b squared equals 1. That's if the hyperbola opens horizontally, like this. Or the other possibility is y squared over a squared minus x squared over b squared equals 1. And that's if the hyperbola opens vertically, like that. All right, so since both variables are squared, sort of in principle, we would need to complete the square for both variables, but for y, it's already, the square is already complete, right? Y is already, the only place y shows up is in a squared term. So we don't need to complete any square for y, but for x we do. And remember, the caveat at the very beginning of completing the square is that the leading term, your squared term, has to have a coefficient of 1. And right now, ours doesn't. It has a coefficient of -1 because of that minus in front. There's an easy way to fix that, which is just whatever your leading coefficient is on your squared term, factor that out. So we're going to factor that minus sign out of our x squared and also our x terms. So that's going to make this x squared plus 8x. And I'm going to leave a little space here. Plus 2y squared equals 18. Okay, so now inside these parentheses, we can complete the square. Remember, once you have a leading coefficient on your squared term, you take the linear coefficient, which is 8 this time, divide that by 2, and square. So 8 over 2 is 4, squared is 16. So we need a plus 16 in here. But the price we have to pay is we need a minus 16 in there as well. Okay, now if we've done our completing the square correctly, these first 3 terms inside these parentheses should be a perfect square. So negative. Now inside these parentheses, these first 3 terms are, looks like x plus 4 squared. And then don't forget this minus 16. So minus 16 right there, plus 2y squared equals 18. All right, so we've successfully completed the square, but remember, we're aiming to make our equation look like one of these two over here. So it seems like this 16 on the left-hand side, we need to get it to the right-hand side somehow. And I guess the first step to doing that would be, let's distribute this minus sign like that. So we get negative x plus 4 squared plus 16 plus 2y squared equals 18. So now we can move our 16 to the left by subtracting it from both sides. So negative x plus 4 squared plus 2y squared equals 18 minus 16 is 2. Now if you look at the equations that we're aiming for up here, both of them have a 1 on the right-hand side. Right now we have a 2 on the right-hand side, so we need to make this be 1 somehow. And there are 2 ways to do that. One would be subtract 1 from both sides. But remember, we just got this constant term to the right. We don't want to create a new constant term on the left-hand side, so subtracting 1 from both sides of the equation doesn't seem like a good idea. The other way to make this 2 turn into a 1 would be to divide both sides by 2. So let's try that. Divide this by 2, divide the left-hand side by 2. So on the left, you get negative x plus 4 squared over 2 plus, and then 2y squared over 2, that's just y squared, equals 1. All right, now this really looks like the equation of a hyperbola. The equation for a hyperbola the unshifted equation for a hyperbola that this looks like is y squared over a squared minus x squared over b squared equals 1. So it looks like for this hyperbola, a squared is 2, so a is the square root of 2, and b squared is 1, so b is 1. And it looks like we have a shift, only in the x direction. It looks like x has been replaced by x plus 4, and that means we have a shift left 4. Remember, shifts usually are x minus the shift, so when there's a plus here, it's really a minus minus. So this is a shift of negative 4 in the x direction, so that's to the left 4. All right, so we can, there are sort of two ways to graph. We could graph the unshifted hyperbola and then shift it, or we could sort of do the shift as we graph it. So let's do it that second way this time. So we need to shift to the left. We're going to have to shift to the left 4. So let me move my vertical axis over this way so I have some room. So 1, 2, 3, 4. So an unshifted hyperbola has its center at the origin. So that's getting shifted left 4. So the center of our hyperbola is right there. So that's the center. Okay. Now this hyperbola opens up and down because the plus is on the y part. So the a distance goes in the vertical direction. So we need to go up and down the square root of 2. Square root of 2 is about 1.4, so almost 1.5. So up 1.5, down 1.5, about like that. And remember, these are both vertices, right? In the other direction from the center, we need to go the distance b, which is 1, so right 1 and left 1. And this gives us this box that we have been using to sketch hyperbolas. Remember, the diagonals of the box are asymptotes. So I guess I should be doing them with dotted lines. And then the hyperbola starts at each vertex and sweeps outwards towards the asymptotes, like this. Okay, so that's our hyperbola. Notice that it does look just like the hyperbola you would get if this shift plus 4 wasn't here. That's just it's moved to the left 4. All right, next example. Let's sketch the graph of this equation, x squared minus 2x plus 4y squared minus 16y equals negative 13. So what sort of conic section should we expect on this one? Well, both variables are squared, and so it's probably an ellipse or a hyperbola, and both of them have a positive coefficient, so probably it's an ellipse. So the two versions of the equation of an ellipse that we might aim towards are x squared over a squared plus y squared over b squared equals 1. And this is if the major axis is horizontal. And the other version is x squared over b squared plus y squared over a squared equals 1. And this is if the major axis is vertical. Of course, how you graph both of these is pretty much the same. So those are the unshifted equations. To see what our equation turns into, clearly we're going to need to complete the square. And since both variables have an unsquared term, we're going to have to complete the square for both variables. So the x terms already have a leading coefficient of 1, but the y terms, so I'm going to leave some space here, the y terms have a leading coefficient of 4. So we're going to need to factor out that 4 from all of our y terms. So we get 4 times y squared minus 4y, and then I'm going to leave some space here, equals negative 13. And now we need to complete the square for both variables. So for our x's, the coefficient on the unsquared term is minus 2. Remember that minus is part of the coefficient. So coefficient is minus 2 divided by 2 and squared. That gives us 1. And for our x's, for our y's, the coefficient is minus 4 divided by 2 is minus 2, squared is plus 4. So in the x, we need a plus 1, but remember we have to pay the price and have a minus 1 as well. And for the y's, we need a plus 4 and a minus 4. Okay, now if we've done our completing the square right, these first 3 terms with our x's should be a perfect square, and the first 3 terms over in the y's should also be a perfect square, and they are. So for the x's, this is x minus 1 squared minus 1. Don't forget this minus 1 right here. And then for the y's, plus 4 times, the first 3 terms in the y part are y minus 2 squared, and don't forget that minus 4 that's on the end, equals negative 13. Now we're going to have to get all of the constant terms to the right, so we're going to have to distribute this 4 here. So we get x minus 1 squared minus 1 plus 4 times y minus 2 squared minus 16 equals negative 13. Now we can move all of the constants to the right. We get x minus 1 squared plus 4 times y minus 2 squared. So we are going to have negative 13 plus 16 plus another 1. Looks like that's going to be plus 4. So equals 4. All right. Now remember, our unshifted equation of an ellipse has a 1 on the right-hand side instead of a 4. So we need to arrange there to be a 1 here by dividing both sides by 4. We get x minus 1 squared over 4 plus y minus 2 squared over 1, but we don't have to write the over 1, equals 1. Okay, so it looks like this equation is sort of matching the unshifted equation x squared over a squared plus y squared over b squared equals 1. So a squared is 4, a is 2, so our semi-major axis is 2. Looks like b squared is 1, and so b is 1, so our semi-minor axis, which is vertical, is 1. And it looks like in the x direction, it looks like we've replaced x with x minus 1, so that's a shift right 1. And in the y direction, looks like we've replaced y with y minus 2, and that's a shift up 2. All right, so now we can put all this together into a graph. Let's see, it looks like the center of our ellipse, the unshifted center of the ellipse is the origin, but we're shifting right 1 and up 2. So our shifted center is going to be right 1 and up 2. In other words, it's at 1, 2. So that's the center. The major axis is horizontal, and we need to go 2 units to the right and the left. So 2 that way, 2 this way, so out there. And then the minor axis is vertical, and the semi-minor axis is 1, so that's 1 up from the center and 1 down from the center. And now we can sketch our ellipse, so something like this. All right, there we go.